Okay, guys, I'm having to do this on my phone, so we'll see how this works out. Okay, so we're starting a new unit, rational expressions. And a rational expression is a fraction. Ugh, fraction, it's not being nice to me tonight, of two polynomials. So here's some examples where you have a polynomial on top over a polynomial in the denominator. You get what is called a rational expression. Here's another one, 10 over x squared minus 6, and then x plus 3 over x plus 7. Just give you some ideas of an example. So whenever we use a rational expression, we have to make sure that the denominator does not equal 0. See, what happens when the denominator equals 0 is you get an undefined expression. So we first have to tell what conditions make the expression, and this will be undefined. So we have to see what makes it undefined. So let's go back to those examples that I gave you earlier. So look at this one. It says x squared minus 4 over x plus 2. So you have to take the denominator and you say, well, what would make that equal 0? Well, if you subtract over the 2, then you get x would equal 2. So if it equals 2, it's going to be undefined. So we do not want x to be 2. So x cannot equal 2. So let's do it on the other side. If we had this one right here, so we would want to set it equal to 0. And then we add 6 to both sides. And we get x squared is equal to 6. Well, then if you take the square root of both of these, you get x cannot equal plus or minus the square root of 6. So that would make it undefined. So we do not want x to be either a positive square root of 6 or a negative square root of 6. If I'm going too fast, it's because I don't have a lot of time to make this video. So you can always go back and I will, and you can rewind. So let's look at number 3. I didn't put that there as an example, but you would have to set x plus 7 not equal to 0, and then you get x cannot equal negative 7. Okay, so now let's talk about simplifying. To simplify, you have to factor the numerator. So we can call that AKA your top of your fraction, and the denominator, which is your bottom of your fraction. And then we have to cancel any factors that they have in common. Okay, so you have to factor the top and the bottom, and then you have to cancel anything that they have in common. So let's look at example 1. If we factor this, we could factor the top. If we factor the top, we could take a GCF out of the top. You take a GCF of x off the top. So if we take x squared, we can take out one of those x's, so we're left with x. Plus, if we take an x out of the 5x, we're just left with a 5 over x. Do you see where you can cancel things? Well, I hope you can say that we could cancel the x's out, and then you're just left with x plus 5. And that is our answer. That is simplified. Everybody okay? So now let's look at this next one. So there's no GCF to take out here, so we're going to have to factor these. So let's factor the top first. So hopefully you guys all remember how to factor. So what are factors of 12 that they have to be not the same sign. So one's going to be plus, one's got to be minus to give us that negative 12. That is going to add, or I mean subtract, to give us a negative 4. So I'm thinking of 2 and 6, because if you have a negative 6 plus a positive 2, that's going to give you a negative 4. So you have a positive 2 and a negative 6. And then we can do dots down here on this one. So difference of two squares, we have x and x, because x squared, if you take the square root of those, is x. And what about the square root of 4 would be 2. And what makes this special is that one is positive, one is negative. So do you see where you can cancel out here? Ooh, right there. So we're left with x minus 6 over x minus 2. Okay, so one thing that we forgot to do in the example number 1 is we forgot to set, I'm going to change to pink, set denominator not equal to 0, or equal to 0, and then you know what it can't be. So let's set these. So x squared minus 4 to not equal to 0. So if you could do this one of two ways. You can add over the 4, or you can just factor it. So if we factor this thing, cannot equal 0. So then you say x minus 2 cannot equal 0, and x plus 2 cannot equal 0. So then you solve. So you add 2 to both sides. So you get x cannot equal 2, and x cannot equal negative 2. So typically those go in your answer. So you might have something that says x cannot equal, this feels very big. Okay. Sorry. X cannot equal 2 and negative 2, something like that, by your answer. All right, so that is how we simplify. Now let's talk about multiplying. First, you factor if possible, and then you multiply straight across. That should be straight. Straight across. And then I did not finish this. And then you simplify. So write, put a blank in there and say simplify. Simplify. Okay, flip over to the other page. Let's do some of these together. So here I don't see anything that you can factor. So you could multiply straight across if you want to. Top and then multiply to the denominator. So if you multiplied, I'm going to show you one way to do this, and then I'm going to show you how to cross cancel. So if you multiply straight across, you get 30, and then x squared times x to the third. Remember, these you add the exponents, so you get x to the fifth, and then y to the first times y to the squared, you get y to the third, all over 20x, and then y to the fourth. Did everybody see that? And now you can simplify from here. So what if instead you wanted to cross cancel and simplify just straight across? So you can simplify up and down. Let's talk about, so you can simplify up and down, and you can simplify straight across like this, but you cannot simplify, you can simplify not straight across, you can simplify diagonal. You cannot simplify like that, straight across. So the first thing that I want to deal with is my numbers. So I see that 5 and 10 that I could cancel those because both of those go into 5. So 5 divided by 5 would leave me with 1. If I divide 5 into 10, I am left with 2. So then let's move on to the 6. 6 and 2. So both of these are divisible by 2. So we get 1, and then 6 divided by 2 is 3. Doing this on this phone is difficult. All right, so now you can simplify. Now, some of you might be like, oh, this is so messy. Some of you are like, no, this is perfect for me. So now I can see that these x's are up and down. So if I have 2 x's on the top, 1 x on the bottom, I can cancel 1 in both of them. So that changes that x squared to the first, and that x goes away. Well, then look at the y's here. I have 1 y on the top. That can go away, and I can cancel with one of these y's down here, and I'm left with 2. But then I have, let's change colors. Now I have my other y's. I have these y's. So I have 2 y's in the denominator and 2 y's in the numerator. Well, those would just completely cancel out. So then what am I left with after this mess? Great question. I'm left with, looks like 1 times 3. So 3. And then what am I left with on the top? It looks like I'm left with an x right here and an x right here. So that gives me an x times an x cubed, gives me x to the 4th, all over, let's see what I have left in the denominator, 1 times 2, so that would give me 2, and then I only see a y left over right there, so I'm left with y. So this would be my answer cross canceled. Okay, so what if we go back over here to this one? So now we can look at it and we can simplify. So what is 30 divided by 20? So we can simplify that down and get 3 over 2. And now let's look at our x's. So we have 5 x's on top, 1 x on the bottom. So if I cancel 1 on each, so I'm left with none in the denominator, but 4 still left in the numerator. And then the y's, I have 3 y's on the top, 3 y's, and 4 y's in the denominator, so I can cancel 3 in each. So I'm left with no y's in the numerator and 1 y left. So you see, you get the same answer either way you do it. So does it matter? No, you choose what is best for you. All right, so now let's look at it when it's got some things that we can factor here. So we're going to have to do a lot of factoring. So let's get started. So in my first one, I see that I can factor out a 4 and I can factor out an x. So then I'm left with x minus 1. Okay, let's go to our denominator. What are factors of 3 that are going to subtract to give us 2? So hopefully you would say a positive 3 and a negative 1. And then over here we have what are factors of 6 that are going to subtract to give us 1? Well, hopefully you would say we would have, what is this? So 6 and 1, so we would have, that would subtract, that would have to be 3, positive 3, and a negative 2, because 3 times negative 2 gives us a negative 6, and 3 minus 2 gives us a positive 1. So now this might be easier to cross cancel in this type of situation, because you can see that you have an x plus 3 and an x plus 3 we could cancel out. You will also notice that you have an x plus 1 and an x plus 1. those can cancel out. And then look over here. You have an x and you have an x, 4x. You have a 4x and a 4x, and those would cancel out. So then we are left here with just one thing. We are left with x minus 2. And that is our answer. Okay. So on this one, we didn't set up our what can they not equal. And I won't ask you on multiplying because it's a lot. We would have to say x cannot equal -3, x cannot equal 1, x cannot equal 0. It'd just be a lot to do every single time. So I will probably only ask you to say what it will not equal, what would make it undefined in your simplifying. Okay, let's do one more multiplying. Okay, so look at this one. Let's factor what we can. We can factor in our first one right here, factors of 15 that are going to subtract. They're not always going to subtract, but this one, these seem to be all subtracting. Subtract to give us 15. So hopefully you'll think of 5 and 3, and we need that to be a -2, so it's going to be a -5 and a +3. So -5 times 3 gives us a -15, but a -5 plus 3 gives us a -2. So it's exactly what we need. So this second fraction is missing a denominator. Well, we can put it over 1 because any number over 1, it's itself. So do you see what we can possibly cancel out here? I hope you can see that you can cancel out an x minus 5 and an x minus 5, and we can cancel out, oh my goodness, we can cancel out an x plus 3 and an x plus 3. So all we're left with here is 1. Awesome. I like this. I like when they cancel things out. It's fun. Okay, so next, let's get into dividing. So when we divide, you have to think of KFC. You're going to have to think of keep, change, and flip. So I'm going to highlight keep, change, and flip. Okay, so keep means you're going to keep the first fraction. Change means you're going to change your division sign to multiplication, and flip means you're going to flip the second fraction. Flip meaning you're going to take the reciprocal. Then we're going to multiply and simplify. So let's rewrite this as a multiplication problem. So remember, you keep the first one. So you keep this the same. So you get 5x over 3x minus 12. So then we're going to, what is this one? This is going to be change. So we're going to change that. So instead of a division, we're going to change it to a multiplication. And then we're going to flip. So we're going to flip this second fraction. We're going to turn it upside down. Literally, we're going to go whoop, 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 whoop. So this becomes an x squared minus 6x plus 8 all over x squared minus 2x. And now we do it just like we did with the multiplication. So we're going to factor as much as we can. So I like to factor everything first. So let's look at this first one in the denominator here. We can factor out a 3. So we're left with x minus 4. Then in the numerator here, I can factor out what are factors of 8 that are going to add to give you a -6. So that means they have to have the same sign of negative. And then factors of 8 that are going to subtract to give me a 6 would be 4 and 2. -4 times -2 gives me a +8, but -4 minus 2 gives me a -6. And on this one, I can factor out an x, so I'm left with x minus 2. All right, now comes our canceling. So cancel what you can see. I can see my x minus 2, x minus 2, x minus 4, x minus 4. I can also see this x and this x can cancel. And then I think that's it. So now see what you have left. Look to see what you have left. I have a 5 in my numerator. Everything else is canceled. So remember, once you start factoring, you do not, this is a big no-no, do not look at this anymore. It's done. It's already factored. So this is done. This is done. Don't look at that anymore. So then what are we left with in our denominator is a 3. So that's it. We have our answer is 5/3. Okay, last example for today. And this is called a complex fraction. A complex fraction is just a fancy division problem. It's got this big division sign separating one fraction from another. So let's just rewrite this as just a simple division. So it would be 3x minus 5x over x plus 5. That's our first fraction. So then change this to just our division sign. And then we have our second fraction of 9x squared minus 25 all over x plus 5. So now we're going to have to keep, change, flip. So keep this one, keep, change, and flip. All right, keep, change, flip. Now we factor and we cancel. So let's factor. Okay, the only thing that I can factor out of this first one is an x. So I'm left with 3x minus 5. Nothing in that denominator. Okay, so x plus 5 can't subtract or can't factor anything, but I can with this one. This one's going to be a dots problem. Difference of 2 squares. So think of square roots. So the square root of 9 is 3, and then square root of x squared is x, so 3x. Square root of 25 is 5, and what makes these special is one's positive, one's negative. All right, so now let's see where we can cancel. And again, remember, these are done now. Don't look at them anymore. So where can we cancel? Well, we can cancel the 3x minus 5 with this 3x minus 5 and the x plus 5s. Cancel those. So what are we left with? In our numerator, we're just left with x, with x. In our denominator, we're left with 3x plus 5. And now we're done. Okay, guys, I have posted a classwork, and if you don't worksheet, and if you don't finish it for in class today, you must do it for homework tonight. I will be checking it for accuracy grade tomorrow. Do only the circled problems. I think that is like 14 problems. All right, y'all have a great day. Bye.